everyone, welcome back to my channel. Today is Godot day 7. In the last video, our snake game was working, but the code was a bit messy. There were no sounds, and the visuals were very basic. So, today I'll clean the project, fix some logic, and add sound effects. So, today I'm doing these things organizing files, managing border and background, adding sound effects, fixing Apple spawn logic, fixing snake boundaries, cleaning old code. These are small changes, but they make a big difference. Okay, first thing I'll go to file system panel. Here I'll create a folder. Let's create it. Create new folder, name it sounds. Created. Inside this folder, I'll add two sound files. Here, I'll add two sound files. I have downloaded them. Downloads. Either you can drag your files and drop here in sounds, or you can do another thing. Go to your folder, project folder, and find sounds there. Within that, copy the sounds you have downloaded in your downloads. Copy them from there and paste it in that sounds folder. I'm doing this so all sound files stay in one place. When project grows, this habit saves a lot of time. Let's add sound support. In the scene tree, I'll add an audio stream player node. This is my scene tree. I'll add a child node for audio audio stream player. Yeah, this one. I've created this. I'll name it sound. Name it sound. This is for when the snake will eat the apple. We'll create another one. This is for game over. Rename game over sound. Game over sound. We have these two sound effects. Now, I'll assign the sound files it sound, it.web, game over sound, game over.web. These sounds are global. They don't belong to the snake or apple position. So I am using audio stream player, not audio stream player 2D. Here you can see here I'll assign quick load. This is for game over. You can see here. I'll choose this. This is for game over, and this will be for it. Yeah, you have here. Now let's fix the visuals. The border is already there. Just change the color to orange. I'll change it. The color is black here. I'll change the color. For orange, we have the hexa code FF9800. Enter. We have orange here. I'm just adjusting the existing border, not creating one again. Okay. Let's create a background. Add child node. Take a ColorRect. Create and name it background. 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 Okay. Let's change its color. It's white right now. We'll change it to dark gray. 2B, 2B, 2B. This is the hexa code. 2B, 2B, 2B. I'll make sure border covers the full screen. Background fits inside the border. This clearly shows where the playable area is. The snake should only move inside this area. Now, I'll fix the draw order. In Godot, everything is drawn in layers. If we don't control the Z index, Godot may draw nodes in unexpected order. That can cause problems like the snake appearing behind the background, the apple hiding under the border, the score going behind game objects. By setting Z index manually, we are telling Godot exactly which nodes should be drawn first and which should be drawn last. This makes the visual predictable. It also helps when the project grows. When I add menus, pop ups, or effects later, I already have a clear layering system. So, this is not just for looks, it's, it's for control, clarity, and clean game structure. Here, I'm not randomly choosing numbers. I'm using a simple layering logic. Lower Z index means it stays behind, higher Z index means it appears on top. So we'll set border Z index to 0 because it's the base frame. So border Z index will be 0 here, 0. Background will be 1. So it stays inside the border. 1 and snake and apple will be 2. Snake will set it to 2, 2. Apple will be also 2 because gameplay objects should be above the background. Score label, it should be 3. Score label ordering, it should be 3 because UI should always stay on top and never get hidden. 3. This way, the visual order is clear, easy to remember, and easy to extend later. If I add buttons or menus in the future, I can just use higher Z indexes values without breaking anything. Let's clear the folder structure here. Let's first will be border, then we'll have snake border, then we'll have background, then we'll have snake, then we'll have apple, then we'll have score label, then we'll have it sound, then we'll have game over sound. Do this only after changing the Z indexes. Now let's go to the script. At the top of the script, I'll define some constants. Let's go to the script. Here we are in the script. I'll define some constants here. Now at the top of the script, I add these constants like border size. I'll take border size const border 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 size equals to 16. Const play area start play area start equals to vector 2 vector 2 border size copied and border size. This will be the x and y axis. Const play area and play area and equals to vector 2 border size plus grid size minus 1 into file size. File size. This is the x-axis and we'll take same for the y-axis. Here I'm defining the actual playable area. Play area start is the top left corner inside the border. Play area end is the bottom right corner inside the border. So instead of hard coding values everywhere, I now have clear boundary for the game. Now I go to the ready function. Earlier the snake was starting without considering the border. So I'll fix that. Go to the ready function. Here we have that snake head, snake snake head dot position equals to vector 2 border size border size plus 5 into tile size. Let's take the y-axis same border size plus 5 into tile size. Here I am placing the snake inside the playable area. I add the border size first, then move the snake a few tiles inside. This ensures the snake never starts inside the border or outside the grid. Now I'll go inside the move snake function. This is where wall collision happens. So I'll fix it. This is move snake function. I'll fix here. Position dot x is less than 0. Now we'll take play area start dot x. Play area play play area start dot x and play area start dot y. This will be the x and y axis. Y and this will not be 640 640. We'll give it to the end. Play area end dot x. This will be end e and d. This will be play area x play area end dot y. Yeah. This was not an indentation issue. I took capital X Y here. This will be small x. This will be y. Fine. Here, instead of checking random values, I am comparing the snake's next position with the play area boundaries. If the snake crosses the border area, the snake game ends. This keeps movement clean and fully aligned with the visible grid. So now the snake logic is tied directly to the play area. If I change the border size later, I don't need to rewrite collision code. This makes the game scalable and clean. Now let's update the eTuple function. Function eat apple. Here is this function eat up. This one. If move delay move delay is greater than 0.05 seconds, then then move delay minus equals to 0.01. Let's add the sound. Eat sound. Eat sound dot dot play. This is the function to play the music, and eat sound play stop to stop the music. Dot stop to stop the music. When the snake eats an apple, first I slightly increase the speed by reducing the move delay. I also limit it so the game does not become impossible. Then I increase the score, play the eat sound, and move the apple. I stop the sound before playing so it doesn't overlap. Here you can see an error, move delay. We have declared this with const actually. Let's do it where const is for constant variables. So now I'll fix the apple spawning logic. In the move apple function, you can see we are taking tile size into tile size here. Plus we'll add the border size also. Border border size. Same for the y axis. Border size. Here I'm generating random grid positions. I multiply by tile size and add border size. So the apple stays inside the play area. I also check that the apple does not spawn on the snake. This guarantees safe and fair spawning. Now I'll update the game over logic. So game over here I'll add the game over sound. It game over sound dot play. Here I'll use await dot await get tree dot create timer. Create This create timer is for sound effect. Await get tree dot create timer. I'll create it for 0.6 seconds dot timer. When the game ends, I play the game over sound. Then I wait for 0.6 seconds before restarting the scene. This delay allows the sound to play fully and makes the game feel smoother. Now, let's change the background size and position. Layout, transform. I'll take it 608, 608, and 608. And the position will be 16, 16, 16. Let's change another thing. Let's take the grid size 19. Now, let's change the size and position of score label. Score label, layout, transform, size would be 40, x-axis, y would be 28, and position will be 24 and 8. We took this size for a 640 screen. So we are designing the game for a 640 into 640 screen. Now we choose tile size equals to 32. Now we need to check how many tiles fit into 640 pixels. So 640 by 32 equals to 20 tiles. So mathematically a 640 pixel screen can hold 20 tiles per slide. We don't want the grid to touch the screen edges, so we add a border. We choose border size to 16. This border exists on both sides, left plus right, top plus bottom. So total border space per axis 16 plus 16 equals to 32. Now subtract the border from the screen size. 640 minus 32 equals to 608 pixels. This 608 pixels is the actual playable grid area. So we took the background to 608. Now divide the playable area by the tile size. 608 by 32 equals to 19 tiles. That's exactly why grid size is 19. That's why I reduced the tile size grid size from 20 to 19. The grid fits exactly inside the screen. No scaling, no stretching, no fractional pixels. Every tile aligns perfectly. The border is clean and center. Movement and collision stay precise. So these values are not guesses. They are the result of exact pixel math based on a 640 into 640 screen. Let's test the code, run the game. Let's check it. You can see when snake is eating the apple, you can hear a sound. When game is over, you can hear a sound also. You can see the border background, everything is in center, everything is working properly. That's it for Godot day 7. Today we focused on clean code, correct logic, and police. In Godot day 8, we'll add a start screen, pause and resume, and improve the UI. Thanks for watching. Like, share, and subscribe, and I'll see you in the next video. Bye bye.